Hey guys, we're going to keep working with our rules of exponents. You should be on page 8 of your binder. You're expected to complete your notes as you watch the video. If you get behind, you can always pause and then restart when you're ready. So our vocabulary, we're going to look at numbers that are using exponents. So if we looked at 5 to the third, the base is the number being multiplied. In this case, it's the 5. And the exponent, sometimes that's called a power, is the number of multiplications. How many times we're going to multiply that 5. So our 5 is our base, and our 3 is our exponent. In the next section, we are going to write using exponential form. That means write with an exponent. So we have -6 5 times. We're going to keep that -6 in parentheses and just give it a 5 and rewrite it a much quicker way. With our x's, we have 9 x's, so that would be x to the 9th. And then we saw today where you could have, or saw yesterday where you could have exponents in a denominator. So this would just be 1 over 8. And we have 8 being multiplied 10 times. We can have a fraction with multiple exponents in it. So we have 1, 2, 3, 4, 5, 6, 7, 4 to the 8th, and then 7 to the 5th. All right, looking at the zero property, for every non-zero number x, meaning 0 can't be the base, anytime x or your base has an exponent of 0, it has a value of 1. So any number, here are some examples. If we had 3 to the 0 power, that would be 1. And you can put this in your calculator and it will show you. We could also do negatives to the 0 power. They would also be 1. And then for every non-zero number x, anytime you have a negative exponent, that is going to be rewritten in the denominator of a fraction. So some examples could be if you had 2 to the -3, that is really 1 over 2 to the third. Another example could be 7 to the -1. That would be the same as 1 over 7 to the first. Really just means bump that number and its exponent down to the denominator. So for this next section, we have to either simplify or evaluate. So any number to the 0 power, we just saw that that's going to equal to 1. Same thing for number 2, even though there's a decimal there, that has an exponent of 0, so that's also a 1. Anytime we have a negative exponent, that means the reciprocal, so that would be 1 over b to the 5th. And notice how we drop the negative there. 1 over 6 to the 3rd would be our next step. Now our directions say simplify completely. So could I go any further? I could. 6 to the 3rd is 6 times 6 times 6. That is 216. So this would be 1 over 216. I couldn't do that with b to the 5th because I don't know what b is. What if the negative is already in the denominator? This is 1 over b to the -9. So like I said, it's a reciprocal, so we're going to move it over to the numerator. So this becomes b to the 9th over 1, or I could just write b to the 9th. Same thing for 3 to the -2. I put it back up in the numerator. 3 to the 2nd over 1, which is, I could simplify that a little further. That would just be 9. All right, number 7, our a to the 3rd, that is, we don't need to do anything to that. I can't evaluate it because I don't know what a is. but I can get rid of that negative exponent. So this becomes a to the third times m to the 6 over 1. I can drop the 1, so it becomes a to the third m to the 6. So you can think about the negatives, meaning just put it in the other part of a fraction. If it's on the top, put it in the bottom. If it's on the bottom, put it in the top. So these two and number 8 are actually going to switch places because we want to get rid of the negative. So the m goes to the top and the a goes to the bottom. We can't evaluate them anymore. We don't know what a and m equal. And then number 9, both of those go to the numerator. So negatives mean the reciprocal. It goes in the reciprocal part of the fraction. M to the 6, a to the third. And again, we can't evaluate them because we don't know what m and a are. All right, let's recap. Our next section was what we did yesterday with multiplying. So we know that anytime we have the same base, we're going to add our exponents. So our first one is going to be 6, and we're going to add the 4 and the 5, and that would be 6 to the 9th. Anytime there is not an exponent, we understand it to be a 1. So I'm going to add in a 1 there. So this would be e to the 5 plus 1, which would be e to the 6th. We can have 3 bases. This would be f to the 6 plus 7 plus 125. So that would be 138. All right, so what I would like for you to do is to pause the video. We're going to write the rule in, and then I want you to pause the video and try 1 through 6 on your own. So our rule is to multiply numbers or variables that are raised to a power. We are going to add the exponents of the numbers or variables with the same base. Remember, they have to have the same base. So I want you to pause, try 1 through 6, and then come back and check your answers. Pause now. All right, remember anytime there is not an exponent, so I'm looking at number 1, that first 3, it's an understood 1, so that would be 3 to the 4th. Our direction said simplify completely, so I can evaluate that. That would be 3 times 3 times 3 times 3, that would be 81. Number 2, we had all m bases, so we just add 5, 7, and 87. I got m to the 99th. Number 3, we could not add the 2 because that base was different, so we could only add the 5, the 1, and the 11, and that made a to the 17th, and then I kept the b squared. That's as far as we can take it. Same thing on 4, I can only add the x's together, and then I can only put the y's together. The bases have to be the same. So x to the 5th, y to the 5th. Number 5, that would be 3 to the 3rd, which is 27. 2 to the 3rd is 8. Multiply those together to get 216. And then again, I can't combine the d with the c's. So that's c to the 21st and d to the 7th. All right, the next example says, what do you do when there are coefficients? Meaning, what do I do when there is this 6, a 3, and a 2? So if we think about it, that's 6 times a to the 3rd times 3 times a to the 1st times 2 times a to the 5th. And the commutative property says I can move this around. So I could do 6 times 3 times 2. And then I put my a's next. And so I can multiply these. 6 times 3 times 2, that's 36. And then I can follow my exponent rules for multiplying. So that would be a to the 9th. 3 plus 1 plus 5 makes 9. So you can multiply coefficients separately from the exponents and their variables. Because this exponent here, the 5 only goes with that a, it doesn't go with the 2. This 3 only goes with the a, it doesn't go with the 6. So we can separate those out. All right, keep going. Go on to page number, where are we at here? Page number 9. So I want you to try that with 1, 2, and 3 here. Go ahead and do the same thing that we did on that last example. Pause the video, answer these three, and then come back and check. All right, you should have gotten 36y to the 9th. That seems very familiar to the last example we did. Number 2 should have been 28x squared y to the 7th. Remember, I can't combine the x with the y, so that's stay separate. And then 30m to the 9th, p to the 4th. Remember, when there's not an exponent written, it's an understood one. All right, let's do some division. So we looked at this a little bit yesterday. 6 to the 5th over 6 to the 3rd, they wrote that out in expanded form. So what happens when you multiply and then divide by the same number, they undo each other, they cancel each other out. So if I keep canceling out as many times as I can, I'm only left with 6 squared over 1. And we got that from 5 minus 3. So we would do 5 minus 3 and get 6 squared. If we have some variable bases, it's the same thing. Every time we multiply and divide by the same value, they just cancel each other out. So that would be 4 minus 2. That leaves me with x squared. So instead of adding exponents, now we're just subtracting. To divide numbers or variables with the same non-zero base, this will not work with 0, but it works with everything else. We are going to subtract the exponents. And I'll explain what the heavier means in just a minute. So 10 to the 7th. We won't do this every time, but I'm just going to do it once or twice. Let's write out 10 sevens. And then 10 to the 3rd. So this is what it means when it says, where is the base heavier? Where do we have more 10s? We have more 10s on the top. We have how many extra 10s? Whoops, I shouldn't have marked that last one. We have 4 10s left over and they're in my numerator. So that means we have 10 to the 4th. All my denominators canceled out. That leaves me a 1. So this is just 10 to the 4th, which was 7 minus 3. I just subtract my exponents. And then it says to evaluate completely. So 10 to the 4th is a 1 with 4 zeros. So 10,000. All right, next one. X to the 25th over x to the 18th. I'm not going to write out all those x's, but I definitely have more x's in my numerator. So my answer will be x over 1. And my exponent is going to be 25 minus 18, which is x to the 7th. And I don't have to write the 1. And I can't evaluate that any further because we don't know what x is. All right, number 3. My 5s are definitely heavier in the denominator because there are more in the denominator and there's 3 more. So I'm going to do 5 and then 24 minus 27, which is 5 to the negative 3, or 1 over 5 to the 3rd. I had 3 extra 5s in the denominator, so I can write it with a 1 on top. And then we are supposed to completely evaluate this. So 5 to the 3rd is 125. So my final answer is going to be 1 over 125. I'll go back and circle my answers here. All right, 3 to the 4th over 3 to the 4th. That's going to be 3 to the 4 minus 4, which is 3 to the 0. And earlier we saw anytime you have an exponent of 0, that just equals 1, which makes sense because these cancel each other out completely. So you end up with 1 anyways. All right, number 5, what happens if there are some coefficients? We can separate this out. So I'm going to put the 12 and the 3, and then the m's. So what is 12 divided by 3? That's 4. We're going to subtract our exponents. 5 minus 1 is 4, so this is going to be 4m to the 4th. We have more 4's in the numerator, so that would be above a 1. Remember, this exponent only goes with the m. It does not go with the 4. All right, next one. We have 6 and 18, and then a b to the 3rd, but nothing in the denominator for b. That's okay. 6 over 18 is 1/3. And b to the 3rd, there's nothing to do there. We can't simplify that. So this ends up being 1 times b to the 3rd, which is b to the 3rd, over 3. That's as far as we can go because we don't know what b is. All right. We're going to do this last little section, and then we'll be done for today. So number 7, 5 to the 3rd over 2 squared. We have to evaluate that completely. So 5 to the 3rd. There are no rules. We don't have the same base. We don't have an exponent of 0. We don't have any negatives. So this just becomes 5 to the 3rd is 125. 2 squared is 4. We can just leave it like that. That's as far as I'm going to take it. You could change it to a decimal if you wanted. But there's no shortcuts with that one because the bases are different. All right, next one. Let's divide up. So put your x's together. Put your y's together. So we have more x's in the denominator. We have 3. So we have x to the 3rd down here. Our y's are heavier on top, and we have 3 extra. So that's y to the 3rd over x to the 3rd. We're just canceling out the extras. Number 9, what happens if we have a fraction? This means 2/3 times 2/3 times 2/3. So that, or 2 to the 3rd over 3 to the 3rd, right? Because that's 3 times 3 times 3, and 2 times 2 times 2. So 2 to the 3rd is 8. 3 to the 3rd is 27. Leave it like that. So when you have a fraction with an exponent, that exponent goes to both parts of your fraction. Same thing here. This would be 4 to the negative 2 over 5 to the negative 2. Remember what we said about negatives? They actually cause that value to go to the other part of the fraction. So these are going to flip-flop. So it'll become 5 to the positive 2 over 4 to the positive 2. We can evaluate that. It becomes 25 over 16. Can't put that in lower terms at all, so that stays as is. All right, last one. Power of a power. So what if you have one base and 2 exponents? What does that mean? So let's look at some examples. 3 to the 6th squared. So that means 3 to the 6th multiplied by itself. So here we have 3 to the 6th times 3 to the 6th. We know when we have the same base, we're going to add our exponents. So that would be 3 to the 12th, which is also 6 times 2. We can multiply those exponents, and that would become 12. 5 to the 4th to the 3rd power. So that is 5 to the 4th 3 times. 5 to the 4th, 5 to the 4th, 5 to the 4th. Now we use our adding rule, 4 plus 4 plus 4. That becomes 5 to the 12th, which is also 4 times 3. So we can multiply those exponents. All right, I want you to pause, try those last 4 in this section, and then check your work. Number 3 should have 2 to the 28th. Number 4 should be 4 to the 25th. 5 is 1 to the 24th, and 6 is 6 to the 8th. So I'm going to jump down to our rule down here. To simplify a power to a power, so one base with two exponents, we know we are going to multiply. All right, that's it for today. You can put these away and have a good weekend.